Hello, welcome back. This is the second video in section 3.4 on properties of logarithmic functions. When you last tuned in, we derived the product, quotient, and power property and the change of base formula. So today what we're going to do is just go through and actually apply these, and we're going to use them to expand and condense some logarithmic expressions. So let's start. We are on page 23 of your note packet. And in example 1, it says we want to expand the following logarithms using the properties. So when they say they want you to expand, they want you to make this so that it's more than just a single log. So the first thing I'm going to do here is use the product property, which says if you have the log of a product, that's the sum of the individual logs of each of those factors. So this would be the log of 8 plus the log of x plus the log of y to the 4th. Then you want to continue and use another property here. You may see we can use the power property over here on the right. We can take this exponent and make it into a coefficient. And we can actually use that on this first one as well, because the 8 is actually 2 cubed. So let me just change that only in the first step. Therefore, this would become 3 times the log of 2 plus the log of x plus 4 times the log of y. That 4 is kind of a mess there. There we go. So that would be as much as we could really expand that first one there. Now let's check out the second one, the natural log of this expression. Here we have, first and foremost, a quotient. So let's break that apart into the natural log of that numerator minus the natural log of the denominator. Now remember, square root means you're raising something to the 1/2 power. So think of this as x squared plus 5 to the 1/2 power. Then you can take this 1/2 here and use the power property and make the 1/2 into into a coefficient, excuse me. Whoops. Try that again. 1/2 natural log of x squared plus 5 minus natural log of x. Now, this is as far as you can go here. Some common mistakes that sometimes people make here is they think they can distribute this natural log. You can't do that. If I distributed that, I would have natural log x squared plus natural log 5. However, this doesn't equal the natural log of x squared plus 5. By our product property, that is equal to the natural log of x squared times 5, not x squared plus 5. So this is not correct. You cannot distribute the natural log. Remember, the distributive property is used when you are taking a value and multiplying it by the sum of two values. I am not multiplying natural log by anything. Natural log is not a value. Natural log is a function. It's just like last semester, if you have the sine of a plus b, does that equal sine a plus sine b? No, it does not. Those are not the same. You cannot distribute this sign, just like you can't distribute the natural log. So do not make that mistake there. Okay. Moving on. Let's see here. On the next page, I'm now on page 24. It's asking us to condense a logarithmic expression. So it's just going the other direction. Now taking these two expressions and combining them into one. And so the first thing you need to do is make sure that you use your power property to move this 2 to be the exponent here. So we'll leave the natural log of x to the 5th, but we'll have minus the natural log of the quantity xy squared. Now that I have one natural log minus another natural log, I can use the quotient property. That would be the natural log of x to the 5th over xy squared. Now, this can be simplified because that squared there applies to both the x and the y. So it's really x to the 5th over x squared y squared. And we can divide x to the 5th divided by x squared. You subtract those exponents, giving you x cubed over y squared. So that's as much as you can condense it. It's in a single logarithm is your goal, and you have, simplified the fraction as much as possible there. For letter B, this is actually just a really straightforward one. Log 5 minus log x, quotient property, that's just the log of 5 over x. Now, I do want you to notice here that I am applying the product property, the quotient property, the power property to logs of all different bases. Over here, I used the properties for log base e, which is natural log. Here, I used it for log base 10, which is common log. It applies to whatever base you are using. If you go back here to the properties, the product rule applies for any base b. And so we're using it for base 10 and base e, and that is applicable. Let's go down to C, which is a lot more complicated, as you can tell here. So again, we just want to combine this all into a single logarithm. So I'm going to, first of all, take care of these coefficients and use the power property to make those into exponents. Notice that that coefficient will apply to both the x cubed and to the y. So it'll be the natural log of x cubed y cubed plus the natural log of yz squared squared. And then you just distribute this 3 here, because raising a power to a power, remember, you just multiply the powers. So this would become the natural log of x to the 9th y cubed plus the natural log of y squared z to the 4th. Now we have two separate logs that are added together, so we can use the product property and make this the natural log of the product of all of these. X to the 9th. Then you've got y cubed times y squared. Add those exponents. That's just y to the 5th. And then z to the 4th on the end. So that would be your answer there. Condensed into a single logarithm, and this is as simplified as that can get. Okay, next here we're going to talk about the change of base formula and how you evaluate logarithms using the change of base formula. Here is the change of base. Remember, if you have something that's in base b, and you want to change it to a different base. So here, if we wanted to change it to base a, it would be log base a of x over log base a of b. Normally, we are going to want to change it to either common logs, so make that a 10, so it's just log x over log b, or you may want to change it into natural log base e, so make that a into an e. All of these are equivalent. You can change it to whatever base works best for you. So what that does is it allows us to evaluate these logarithms on our calculators. Now, actually, the new operating system, so if your calculator has a relatively new operating system, you don't even really need to do change of base to find these. Instead, you can just type it in exactly as is. So let me see if I can remember here. I think it's alpha. No, let's see, alpha window. Yeah, alpha window. And then choice 5 is log base. So if you just choose choice 5, you can just type in log base 3 of 13, and there is your answer. So remember what that means is that if I raise 3 to this power here, this 2.335 power, I will get 13. Let's just test that. 2 raised to that power, I'm just going to use my answer choice here. Oh, that didn't work. Oh, I was supposed to be doing 3 to that power. Excuse me. Sorry. 3 to that power. There we go. Oh no, now I used the previous answer. Oh my gosh, this is a disaster. 3 to the power, I want this up here is what I want. There we go. 13. Okay, 12.9 repeating, which would be 13. So that means log base 3 of 13 equals 2.335. Okay, ignore this stuff in here. That's all wrong. All right, so that's how you can do it if you have a newer operating system. Now, if you don't, you're going to need to use the change of base formula. You should know the change of base formula anyway, even if you do have the newer operating system. And you just want to change this to like base 10. So it's, well, base E is what I did. Natural log of 13 over natural log of 3. So if you go back over here, and you do the natural log of 13 divided by the natural log of 3, then you get that same answer, that 2.335. That's the same thing we got when we put in, let's see, we put in log base 3 of 13. Same result. Now, keep in mind, you don't have to use natural log. You can use common log. So you could do common log of 13 divided by the common log of 3. Same result. You can use whatever base you want there. So just keep that in mind. Okay, and so we got an answer of 2.335 approximately. And then you would do these other two the same way if you're trying to find log base 6 of 10, log of 10 over log of 6. Again, it does not matter what base you use. You can use natural log or common log. So log of 10 divided by log of 6, 1.285, or natural log of 10 divided by natural log of 6, same result. Or if you did the, with your log base here, log base 6 of 10 is also 1.28509. And remember what that means is if I raise 6 to that power, that gives me 10. Okay, so hopefully that is clear to you. Now the only other one on here is this log base 1/2 of 2. Of course, you can do that using the change of base formula as well. Let me write this answer here. 1.285 is what this one was. That's just the log of 2 over the log of 1/2. However, what you might notice about that one, if I do that here, log of 2 divided by log of 1/2, I get -1. I already knew that just by doing it in my head, because I know that 1/2 to the negative 1 power is equal to 2. So that one we could have done in our head, really. Okay, so there is the practice on using the change of base formula. I think you should be able to do all the problems in the homework from this section after this video here. So go ahead and work on those. There is a third video talking about some of the applications. See you later.